Welcome back to our Physics 141 demonstration series. Today, we are going to measure the speed of sound in air by using a tuning fork of non-frequency. In our case, we have a tuning fork with a frequency of 512 Hertz. And a resonant tube, which is basically a closed open cavity. So by measuring the length of air columns where the resonance occurs, we are able to determine the wavelength lambda. And since we know the frequency, we can determine the speed of sound u using the speed wave equation that says that u is equal to the wavelength times the frequency. So now, how are we going to determine the wavelength? Because the boundary conditions here have a closed and an open end, this means that we need a node and an antinode. This in turn means that the standing waves are going to form when the air column L is equal to n times the wavelength of sound divided by 4, with n equal to 1, 3, 5, 7, and all these odd numbers. In order to avoid boundary effects, which have a correction of 0.3 times the diameter of the tube, we are going to use the first harmonic, for which the air column, the length of the air column is equal to the wavelength divided by 4, and the third harmonic, for which n is equal to 3, so this means that we have 3/4 of lambda for n equal 3. So we are going to determine the difference between L3 and L1, delta L, which is 3/4 of lambda minus 1/4 of lambda, and this is 3/4 minus 1/4, 1/2, so this means that delta L is equal to lambda over 2. And so then the speed of sound is equal to 2 times delta L times the frequency. So now what we need to do is determine the length of the air columns. In order to do that, we are going to use these systems that has 2 pipes, one which is the measuring pipe that is fixed, and a water reservoir, such that when we move the water reservoir up and down, the level of water will be moving up and down, and this will allow us to precisely determine the length of the air column. So Jorge will be moving the water reservoir while I produce the sound wave, and we need to determine where the first and the second and the third harmonic take place here. So let's do it. There we have one. And there we have the other one. That happened roughly at 16 centimeters. So L equal 1 is 16 centimeters, and L equal 2 is 49 centimeters. This means that our delta L is 49 minus 16, which is 33 centimeters. And so 2 times delta L is equal to 0.66 meters. So now we have a frequency of 512 hertz and delta L of 0.66. So 512 hertz times 0.66 meters gives 338 meters per second. And this is all, folks.